Because you might have some HCl left, but maybe not. It depends on how you wash it. So the first washing is going to go in here, so it's going to be kind of acidic. This is kind of acidic. This is why you have to, since it's kind of acidic, this is why you have to make sure you neutralize the acid, the HCl that you added in step 1 that came over in the washing. You got to neutralize that, and then add the ammonium. But anyway, this is going to give you some rust PPT. And so here it's just the iron 3 plus 3 ammonia plus 3 waters. This is a metathesis reaction with using aqueous ammonia. Yields iron 3 hydroxide, solid plus 3 ammoniums. The ammoniums, the addition of the product there is to help buffer it, that is, control the seesaw balance of this particular reaction. All right, then what we did was we added the hydrogen peroxide, correct? The hydrogen peroxide, the purpose of the hydrogen peroxide is not to react with this. The purpose of the hydrogen peroxide is to react with the chromium precipitate. And so precipitate 2 should be untouched by the hydrogen peroxide, and so we should write this out. This would be the observation, so I want to see precipitate whatever reacting with hydrogen peroxide yields no reaction, so we have iron 3 hydroxide, which is already pretty well oxidized already. It's not going to be oxidized further with hydrogen peroxide, so we get no reaction here. That's 3. Okay, then we go on to 4. The hydrogen peroxide was to get rid of the chromium, or to, and then we have the hydroxide. The hydroxide is to get rid of the aluminum. And so here we'll go with precipitate from step 3 plus the sodium hydroxide yields NR. And so this is step 4. We don't want our precipitate. And so this would be the observation, this first one, and the equation would just be this. Whereas aluminum will react with that, the aluminum hydroxide. All right, then step 5 is finally we add the HCl. Now we got the iron alone, so we're going to get the precipitate from 4 and then add HCl, and then we should get a clear yellow solution. And so here we have our precipitate. We'll add the 3H plus, and this gives us Fe3 plus 3 waters. The driving force for these we'll go through in just a moment, but that's what we see here. Okay, then what's the next step? Step 6, what do we add? What do we add in step 6? Keith, what did you add? All right. And so what we'll do is we'll take this solution from 5 and then add potassium hexacyanoferrate. What's the charge on iron there? Is it iron 2 or iron 3? And the way we can tell is based on the formula. And so there's 6 cyanides here. And depending on how many potassiums we have here will tell us the charge on the iron. Because each cyanide is -1. And so this is -6. -6 plus something is going to give us minus something, which we have to balance out with potassium. How many potassiums are on? Here. 2, 3, 4? 4 potassiums. So that's 4 positive charges, which means iron must be what? Iron must be +2. And so this is called potassium hexacyanoferrate 2, Roman numeral 2. And so we add this. This is this solution you'll find like in the dropper bottles along the walls here. The sodium hydroxide is kept in another, the HCl is kept in another, but potassium hexacyanoferrate is kept in a small dropper bottle. And this is aqueous. And then we get a blue precipitate. This is a very famous reaction, like a Prussian blue precipitate. And so over here, we have iron 3, and it's going to react with this anion. And this anion is kind of a funky anion because this anion is going to be a 4 minus anion, right? Because we needed these, so this is a 4 minus anion. And so we got to figure out the ratio. One way to figure out the ratio is this Chem 1A trick. We drop the charges down as subscripts. So this will be Fe4, and then we'll have to have FeCN6,3. This is a solid PPT. And then what? Are we at the end? Are we at the end of the line for iron? Yes?
Yeah.
Once we reach this point, then we say we have a positive test for iron 3. There was iron 3 in our solution. This one works okay. And so this is what I'm expecting for each of the cations. You start from square one, and then you go all the way to the end, like game. And so we just chart out the path it takes and follow the ion along the analysis path. All right. So after iron comes what? Chromium or aluminum? All right, either or, yeah. So do either aluminum or chromium. And then start at square one, way back at the original unknown, and then just follow it along. And make sure you know, as chromium goes through this, what to expect for chromium and what the equations are. Well, I told you we'll look at the driving force. For some of these driving forces, there's no driving force here. This precipitate would be the driving force here. There's no driving force here. No driving force here. Here, we're going from stronger acid, H+, to weaker acid, water. Here, precipitation is the driving force. These, let's look at the types, reaction types. This is metathesis, redox, metathesis. So we got a whole bunch of metathesis reactions. All right, so either do chromium or aluminum, and then I'll check these as we go along.